Welcome everybody to today's session of AI Suisse, and I also welcome Yannick Horst with me. Hi Yannick.
Hi Stefan, how are you doing?
Where are you located?
Yeah.
Where are you located?
Where I'm located, I'm in Berlin, Germany right now. So yeah, up the east of
Very north. Okay, interesting. I hope you had a great day already today.
Yeah, certainly. I mean, the weather is nice and it's getting warmer and warmer here, and summer is definitely the nicer part of the year to be up here. So it's definitely have been a good day so far.
I mean, I like it. Thanks very much for joining us today. You bring actually a very interesting subject with your responsible AI, which is one of the major topics which we have in the market at the moment. So for everybody who has just joined, with me is Yannick Horst, who is the presenter today. And we will talk about responsible AI, but it will be not a theoretical talk. It will be really what we need to do about it, what we need to think about it. It's very hands-on, which I like. And for everybody who is just the first time with us, there's a Q&A section in the navigation. If you check your navigation bar for a moment. So if you have questions you would like to ask during the presentation, feel free to ask your question and be reassured there's no silly question at all. So please ask and I will take care of it. Yannick can fully concentrate on presenting and answering the questions basically. And so we can fully go into the process now. Yannick, responsible AI, why do you talk about that? What's your daily work, daily profession? What do you do in your daily life?
So my role basically is as a data science advisor at a SaaS software analytics company, is to help our customers and clients in different industries to realize their ambitions, to implement analytics models and intelligent decisions in their operations. And one thing that emerges and basically was there from the get-go is the problem of having biased data, having issues with bias in models. And this forms more and more into this bigger subject of responsible AI, which has lots of facets. It's very, very complicated. And what I do is help our clients to kind of translate this very abstract and very nuanced topic and try to show them how they can actually implement that in real processes.
Interesting. Have you observed any kind of changes regarding the last 2 years regarding responsible AI? How do the companies actually feel about it?
Definitely. I mean, companies that took AI seriously a couple of years ago already, or like really invested heavily into it, they sooner or later got to the point where they realized that they have to have some systems, some teams in place to actually deal with that subject. And what we saw over the last year, and especially like the last month even, it's evolving and it's becoming more and more important and more apparent that we have to tackle it somehow. There is so much research going into it on the academic level, and organizations, a lot of times struggle to really get a grip on it and see how they can actually assure that their system are actually compliant and ethical. And then again, especially on the regulatory side, we see lots of development, and we can expect even more changes rather soon.
Interesting. So it's not a nice to have anymore. Is that correct?
Yeah, definitely is not. It definitely will be more of a requirement, and actually, I think not dealing with it now or like start dealing with it is actually, can get really, really bad really, really quick. And I think, it's definitely not a vanity project, not a vanity thing. It's a necessity at this point.
Okay. So you talked about regulation as well. So there's, it looks like the pressure is on to change something in the corporate world, right?
Yeah, so, definitely.
To what you actually tell us. So feel free, take your floor, please. And I'm really looking forward to listen to you.
Okay, so let me share my screen then. There we can go. Yeah. So you can just let me know for a second if you can see everything.
Screen is up.
Perfect. Yeah. responsible AI in action, we're going to have a look today how we get this very abstract topic and get it into a workable context and really see how this can look in a real example. And one thing I want to mention just from the get-go, this might not correspond or really everything we're going to see is not actually what you do in your day-to-day work. It might only be a part of it, but it still helps you to see how this whole process end-to-end works. And I think we all can learn something of that and how we have to structure hands over and, just have a better experience being in an analytical organization. And I want to start with, setting some expectations, what you can expect here. I mean, we just hit on that a little bit. I want to touch on a quick, what is responsible AI and why do we care? I mean, we just mentioned some of it, but I have some additional parts. Then we go into the demo, which is basically the main part. And in the end, we look at why this could be a competitive advantage, not just a burden we have to deal with. Also, what you're not gonna should expect from this thing is we're not gonna have a deep conceptual discussions about responsible AI. This is not the place here right now. It's also not about specifics of upcoming regulation, not about explainability methods or a specific responsible methods. We will really touch on those here and there, so they will be incorporated in some fashion, but we won't go into technical discussions because this is definitely way too much and requires whole hour-long sessions in by itself. Yeah, we can basically jump over that. Just maybe as a side note, yeah, I'm a focus mainly in my work at SAS, developing operationalization, intelligent decisions, and privately, I really like to run around with cameras, fly my drones. That's usually what I do. And to round this up, who is SAS actually? So SAS, if you're not familiar with that, is a company that has decades of experience when it comes to business analytics. Some people might even say we kind of founded this, industry of modern analytics software. We have lots of customers in the Fortune 500, and a lot of times we get mentioned as the number one AI analytics software vendor. But yeah, that's all about you have to know SAS for this at this moment.
I think you mentioned it before we started the session today. So you said SAS is going to invest 1 billion into developing AI, right?
Yeah. So we, as you can see, actually on the backside, we reinvest 75% annually in R&D. And we had a flagship event, the SAS Innovate, just recently, and there our R&D had actually pledged that we will spend another 1 billion specifically on AI development in the next 3 years. We actually have done this in the past already, but we continue to spend heavy money on that subject because we know it's will be important for the years and decades to come.
Do you have any core focus in what areas do you spend the money? Is that clear?
Literally across. So we have, we will see the platform a lot today, so there will be lots of spending there, but especially also our solutions, our industry solutions will benefit heavily from that. So yeah, specialized AI models and AI functions that help customer intelligence, have our fraud solutions, our energy utilities. It's really across the board.
Okay, thank you.
Yeah, but to get started, this whole topic obviously doesn't really exist in a vacuum. It has a context. There's stuff around that, and we should acknowledge that at least for a little bit. And the 3 reasons we actually already touched upon, but I just want to reiterate that because it's very important why you should actually care. And yeah, you really should and have to care. The first one is ethic and social responsibility. Don't really think I have to explain that too much. That avoiding to be the next headline, and regulation that is coming soon. Like I said, ethical and social responsibility. We develop systems that affect humans, human lives, and human livelihoods. So we should care about that and really should make sure we act responsible so we don't let any unfair treatment slip through the cracks, basically. But even if that is not reason enough, and you see, well, I need a business case, basically. Well, avoiding to be the next headline saves you money, basically, because if major scandals erupt in that field, and there's actually websites that specifically track AI scandals, this, saves you from customers leaving, because if they feel that you treat their data or treat them unfairly or unjust or don't care about that, they will leave you for sure. But actually the kicker is the next part, the regulation, where we aren't really sure how it will look and what it will be yet. But if GDPR is anything to go by, not complying with the regulation that will come up, it probably is going to be very, very, very sensitive and very expensive. So that should be reason enough why to take this thing seriously. The next thing is, like I said, I won't really go into much detail because this will really get out of bounds here. But responsible AI as a concept has lots of facets. So you have the algorithmic fairness, you have the robustness of a system, you have privacy, you have ethics. But across all those facets, basically all those pillars, there are two things I want to highlight here, and that's the accountability and transparency. Those are things we need for everything, and we need it across everything. So that's something we really have to make sure of, even though we deal with everything on top, every pillar. If we don't have accountability and transparency, we really lack major parts and basically the basis for everything. Mm-hmm. And just to kind of make the transition easier now and to better understand the process we'll go through in just a minute, I want to introduce to you the analytical lifecycle. It's a concept I think some people might already be familiar with, but it basically is how we look, especially at SaaS, at the quest from coming from a business question and then actually making a decision. And this goes from accessing data, preparing it, then building a model, putting that in production, monitor it, and making decisions on that. And it's not a one-way street, it's really iterative. And if you kind of are familiar with this, you will see this has very much similarity to DevOps or model ops. And this similarity is without, it's not an accident. It's actually very, very similar. And we actually mentioned DevOps, model ops and data ops, especially in just a second. Yeah. And also, before we start, 3 things are very important, as always, to actually make this happen. We need people. So it's not just a person's job. It's not a group's job. It's people that do all those things. All those are important. We need a process, we need processes, and we need technology that actually supports all of that. Mm-hmm. Yeah. So that was basically the setting the scene part, kind of introduction. So why it's important and where we're actually coming from. So let's have a look at the actual main part, doing responsible AI in action. And I like to do it at a real example, or a fictional bank in this case, but it's a real demo, or a real use case we have in the end. And we talk about today about Ethics AI Bank, and I think kind of the name tells it all. And the people we're going to talk about here are, we have a data engineer, we have a data scientist, and a deployment manager. Those are the 3 roles we have right now or today in our story. This obviously really depends on the organizations. If you have 5 roles, 7 roles, 2 roles, how the name's called, this is obviously dependent, but I think you get the idea in the end. And the goal today is to make a credit application process more intelligent. Very simple example, very basic, nothing groundbreaking, but it helps us to kind of get the gist about what responsible AI action is about. So we have people. And because technology is everything we were going to see from now on, I want to touch on the process again a bit. There's lots of things happening in this thing, and we will skip over so many parts. That's why I want to highlight certain points I want to stress in every part. So in the data ops part and data engineering part, we care about data privacy, we care about data quality, and we care about bias. When we model, we want to have a fair model, and we want to have it explainable. And when we have the model in production, we want to have governance, we want to have it monitored, and we want to have auditability about the decisions we're making in the end. And again, accountability across everything. So enough talk. Let's get the abstract into the real thing. And basically what you see is the same thing I just showed you. It's assess data, develop a model, and operationalize and govern. But it's not just, a BPMN diagram you just see here. It's actually the first puzzle piece we need, and that's a business process engine. Basically, helps us to define all the aspects that we have to take care of to ensure accountability and make sure we checked all the boxes we have to take, to make a system sound and make it safe and make it fair. And that will basically guide us. And, we just skip over the define objective and model proposal, which we say we kind of kick off this whole thing and dive right into the work of the data engineer, where we want to check data privacy, quality, and bias detection. Yeah. And
just in between here, because he used accountability, and it's about responsible AI. So accountability, how do you distinguish that from responsibility?
Well, responsible AI is basically about the concept that I think it's more the holistic concept with all those different facets I just showed, with the model fairness, the bias, the privacy, etc. And accountability speaks here. Okay, we really can tell. Okay, somebody or this organization, this team is has to take account for something. One thing is about, okay, we want to make sure everything is safe and sound. And obviously there is some overlap here, but when I say accountability, it speaks about that we agree on it, that everything is cool, but actually we say this model got approved by somebody or by some group of people. And it's about having it visible and having somewhere set in stone that somebody that vetted it, approved it. That's accountability in that context.
Okay, and you showed the workflow manager in the slide before. So we actually need some kind of process to find the right place for accountability or responsibility. I think accountability sounds for me more like, you really need to take the responsibility. It's not more like a concept. It's more like we have to.
Yes.
You need to structure that, and it looks like the workflow manager might be a tool to actually understand which people and which process levels or phases actually demand for that kind of accountability. Is that correct?
Yes, exactly. So because it's in the end, somebody has to approve something, somebody has to do something. And we have that in so many industries, like when you look at the accounting, if somebody has to sign off a quarterly report in the end, or public companies have to do that. And that's kind of the same thing. You have accountability that's, this actually was done properly. And that's what we have to do, obviously, in some way that's trackable. And we're going to do that with a business process engine, as you just saw.
Interesting, Evan, because you're showing data engineer on that slide as well. So it's a very operative role. So responsible AI is not management task, right? Is that correct? Or would you say this is just everybody's task in some ways, different in his or her role in the process? Is that correct?
You're getting a bit ahead of me, but yeah, that's actually what I'm alluding to. It's not somebody's, it's not the job of a single person, but it will take everybody across the chain to really, it's everybody's responsibility. Everybody has to take account for something.
Thank you.
Cool. Yeah, let's jump into the works of the data engineer. Like I said, we're going to start here with the tooling part. We're going to see lots of interfaces here. But here right now, what you see is, it's called the information catalog, which basically is like the name says, it's a catalog for data assets, databases. It basically crawls data sets that are in the environment. It crawls databases that are connected to it. And what we're going to do here is we want to model credit card applications. We look for loan data set. And we actually know already which one we want to use. That's the CS accepts here. And just with a click, we already start here to work as a data engineer to vet this data set. So for example, we see very high level, we have 26 columns, 3,000 instances. And we have 99% completeness. So it's not 100%. And we see as well that we got some information privacy flags here that got automatically detected. So we're going to check those. Then we can check basically the same thing on the column level, where we see some descriptive analytics or measurements to kind of get a feel for the data, and kind of, just with some clicks, we can, see if there's any issues. So for example, for missings, we see a resident ID has some missing values. This might or might not be a problem. When we look at the income distribution, we see, okay, this is rather skewed actually. So that might be something we have to take into account for. So very easy without, much intervention, we can actually go in and vet this data set. And here again, in the data quality tab, we see, for example, more information about the information, like the privately flagged attributes, and they got detected as like semantic type age or phone, for example, and that is detected as private and as a private attribute. And we can get them more information on those and see if anything's going on here or how we want to deal with that going forward. And also lastly, for the attribute nationality, we see actually that we have a huge population of German customers here, but not so many for other nationalities, and that might be an issue. But for the sake of now, we just say, hey, this actually looks all good, and we can work with that going forward. And then we will actually have a look at the task pane, where we kind of check the boxes as I alluded to before. And the first thing I'm going to do is we're going to approve that data privacy is not an issue. I mean, it got flagged, but it doesn't mean that we can't use it in this instance. I mean, this is a policy question. That's something the data engineer has to decide in this instance. It's just like a thing that like highlights you potential problem, but it doesn't mean it is actually a problem. And when we check that, we actually get the next task of assessing data bias. And the first thing you have to do is to claim it, because obviously we work in a team. Usually everybody can do certain tasks, and we have to claim them first before we can then go forward to actually check them. And here we're going to say, hey, yes, we actually found bias in the data, and the data scientist has to take care of and has to be warned about this. But it's not bad enough that we have to like reassess with the business team, maybe. So, and after that, we get a little Teams notification, and the data science team basically says, hey, your data got approved for the project, but also we get a warning that you have to take care of, especially about some sensitive groups like title and nationality here. Yeah, so that's basically the first handover point. Now it's basically the data science team that's taking over and starts developing models. And the things we take care of, like I want to reiterate it here, is we want to have explainability. So we want to explain the decisions we want to make in the end to auditors, to our customers. And we want to make sure that the decisions we made or the models we develop, they are fair and do fair decisions across different groups with sensitive attributes. And for that, we're going to go into our modeling tool. This is basically just one interface. I will show the same thing in a Jupyter notebook just in a second, but it makes it much easier here right now. And what you see is a modeling pipeline, which basically allows us to have different data pre-processing steps, have different models, have different settings for each model, and train them all at once and then compare them to see what actually worked best. That's Model Studio for us here. And what we're going to do here real quick is for this ensemble model, go in and say, actually, please generate some interpretability graphs for us. We will have a look at in just a second. And then basically, we're just going to click on run pipeline, and then it will take our training data and run through this whole thing and train all the models, and then we can do the comparison, which will look as follows. We're going to have a look at what worked best in this instance. Just really quickly, based on the Kolmogorov-Smirnov statistic, if somebody's interested, we can basically choose that, but in this case, it's KS. And we see that the ensemble model is the best one in this case. And then we want to go and actually have a deeper look in this specific model. And here we see lots of information about it, but for example, the different models that went into this ensemble. But we are about responsible AI. That's why we're going to have a look at interpretability to see how actually the model decides stuff. And here on the top right, you see the first global explanation method, a partial dependency plot. It's if you want to read up on what those actually do, but they basically help you to kind of decide how the prediction chains with a change in the attribute on average, basically. But it's obviously way more nuanced than that. But there's different plots that help you kind of like really get a view and a feel about like how this model actually works. But we can't only do that like on a global level, but also look at different instances. And here, for example, we have the instance 1000696. And here we see how the values for each attributes contributed to a different prediction. That's a local explanation method here that helps us to kind of decide and interpret, even if we use a black box model, how we actually get to a certain decision. The next one is we're going to have a look at the performance, actually, because it's cool to interpret a model, but we also want to have a good performing model. And for that, we see all the graphs that just like get generated for us. For example, the ROC curve here. And what I actually just forgot to say, for every graph you have, you get those like natural language generated explanation of those graphs, all the numbers, because, you know, it's always good to read up on it. Sometimes I forget, okay, what does this actually do? And also not everybody is familiar with all those graphs. So this kind of helps with that and makes graphs more accessible and understandable what actually happens here. And last but not least, we have to assess also the bias. And as we had before, we see that across the attributes we checked as sensitive here, we see there's apparently a bit of a problem when it comes to nationality, because on the top right corner, we see the maximum bit prediction difference. So there's like seems to be, you know, a bit of volatility here. So we have a look at that. And also when we look on the right, left, we see, okay, there seems to be an issue.
And then for a moment.
Yeah.
Since our subject is responsible AI, there's a tab fairness and bias. So you actually build or you show us a software which includes the topic of responsibility as an analytics element. Is that correct?
Yeah.
Okay. And how is fairness defined here?
Well, fairness, fairness in this case is we have different sensitive groups. We want to make sure that we don't treat differently. So there's, I mean, some obvious ones are like gender, nationality. There's like stuff we don't want to discriminate against. And we know those are sensitive values. And here fairness basically is, do we treat those groups equally, or can we detect if there's any like, mistreatment due to some bias in the data, bias in the methodology, etc. So this basically helps us to assess that. That's basically fairness in this case.
Okay. So model interpretability helps you to understand if a model as such might be wrong, biased, or you have a problem to explain in consequence, or?
Well, interpretability, it can help you with that, but it's more about, the focus is more to understand in general how the model works. So understanding how age, how income, also how nationality maybe has a role. By fairness and bias really then focus on those sensitive groups and show and try to highlight, okay, we have some, mistreatment or different kind of treatments for different groups. While the interpretability is more about really understanding how a model works within itself.
That's okay. So that would be helpful if you write transparency reports and how the model works itself.
Yeah, you need to do both. You need, for one, you need to prove that you don't have bias and you don't have any issues with fairness. But then also you have to explain to regulators and auditors how your model gets actually to a certain prediction. That's things you have to do both. It's not just one or the other. It's both you have to do.
Mm-hmm. Okay.
Yeah, but yeah, as you can see here, then across the different nationalities here, and as you can see, that's basically performance, and you see then again three different metrics each for different nationalities. We see that we have apparently some issues when it comes to to the true positive rate. We just look at that for a moment. So for lots of European countries, this doesn't seem to have an issue. But for Yugoslavian people, this metric is 0, which is not so great. And also when we look at the average prediction for a certain group, Yugoslavian seem to have definitely not the best here. So this is one, for example, one example of how this can be problematic in this instance. But we're going to deal with that at another point and just say, actually, this works fine for our purposes right now. And we will actually take this model and put it into our repository now, which is basically the central space where we manage and govern our models, and where we can actually take them and put them in production and check them from time to time, etc. So just with click on the button and the model is actually registered. And I promised to show the same thing in Python, because not everybody is actually a SAS developer and likes to use graphical interfaces. But just an example here, you have this linear explainer method, as you can see, which basically you can use in YouTube's notebook, and it lets you use a linear explainer on it, and kind of gives you the ability to use the same explained functionalities as you just saw on the graphical interface in an open source environment, which is basically one of the things we pride ourselves with, that we really embrace this concept of bring your own language, basically. So everything you see in the graphical user interface is actually, you can use that over an API or a package, like in this case. So even though, for example, you are a Python developer or an R developer, you can still use the same tools. Another example for that would be the assess bias we just saw. Here we, for example, again, take our sensitive variable nationality, take our model, and then look at the true positive rate and see, for example, in this case, we don't seem to have such a big issue with true positives across different groups for nationality. And last but not least, we also have then to take this model and put it into our repository to work with it further. And also that it's very easily possible with some lines of Python code. It's usually something people want to see, that it's not a walled garden. It's actually a very, very open platform, and whoever is developing a data science team can work with it. And that brings us to another message, and this time it's for the deployment manager, because modeling is finished. And here, like I said before, now it's time to govern our models, manage them. We want to monitor them, their performance, and we want to make sure that we can audit the decisions we're making. But before we're gonna jump into that right away, I want to go back to this overview and actually have a look into the sub process, because it's a bit more complicated than the other ones. And the things you're going to do here is, first of all, you're going to set a champion and challenger model. Usually you have, for a certain project, multiple models, and then from different teams, from different people, and we have to pick one we're going to actually use. Those can also change, and that's we have challenger models for, where we say, actually, right now, this one's going to use, but this one might be the next one. Or we use multiple models at the same time, as we will see in a second. We have to integrate the model into a decision logic, more on that in just a second, and we have to profile the decision. But as you can see, there's more here than just we will go through now. So this loop here signals that on a regular basis, we will have performance monitoring reports created automatically for us. This is designed for automatic tasks, basically. And then somebody from the deployment team will be prompted to assess this report and say, actually, this model is still good. Maybe we have to retrain it, or we have to rebuild it from scratch. And based on that, and manual or automatic task will get triggered. So this is basically model ops in a nutshell. And we only will have a look at a couple of those right now. And that brings us already into our model manager, our model repository, where we're first of all going to go into the project we're going to talk about today. And the first thing is obviously we're going to have to compare both of the models we have right now to see which one is actually better and which one we want to use going forward. And this function, basically a method, helps us very easily to get a side-by-side view, get all the fit statistics for different data sets, get all the graphs, and really get an objective view on how the model performs. It's usually more than one metric you want to have a look at, but this makes it very easy to compare those side by side. And the next thing then, after we had a look at all the models and stuff, we want to set our champion, our challenger. And as you can see, the ensemble model is already set as a champion based on that purple icon. And we're going to set the other model as our challenger in this case. Cool. So one thing I thought about doing a little intervention here to kind of make things clear I want to do in the next minute. We have two models now. We have a gradient boosting model that has some bias, and we have a Python model that performs a bit worse, but basically it doesn't have the same issues when it comes to nationality, at least. And what we want to do is, in the end, we have applicant data. We have applicants that want a credit from us, a loan, and we're going to take the attributes, give it to the model, and the model tells us 42. That's great, but that doesn't tell us anything. It isn't decision. It's just like a prediction that we have to then put into context and actually put some rules around that to actually make a decision. And that's where we want to say something.
No, is that okay?
We get to the intelligent decisioning part, like enclosing a model and the prediction into some business rules. That's very, very important because a prediction by itself is not a decision, and that's what we're going to do here. So we're going to combine machine learning models, business rules, data queries, if you want, third-party systems to get from the is somebody creditworthy question to we actually approve or decline a credit card application. And we're going to do that. And the next, hopefully last but not least, tool, intelligent decisioning. And it's very simple process here, but basically we're going to check first of all, is somebody over 16? It's a very overly simplified example. Then we check for nationality, and if somebody is German, we're going to use the model we developed first, because then we didn't have too issues with German applicants, but with others. And then we're going to use the other model for the rest. And that's actually might sound and look a bit weird, but that's actually one way we have clients in all different industries dealing sometimes with those issues. But this is definitely not something that's a one-size-fits-all solution, but in some cases this can work. But the next thing you saw, we just skipped over it a bit quickly, but after we kind of ran inference on our applicants, we don't have credit risk rules, which basically tell us now, okay, with the value of 0.35, for example, somebody is low risk, and we give them the approval offer with a competitive interest rate. If somebody is under a risk of 0.5, it's medium risk, and we give it a standard interest rate. And if somebody is over 0.5, that's actually high risk, and we decline this loan. And that's basically what I mean with, okay, we have a prediction, but now we have business rules that actually help us make a decision here. And obviously, because we have, not just models here, but decisions, rules, we have to profile this decision, because we can have the unbiased model in the world if our rules are biased or have some unfairness in them. Doesn't really help us. So we're going to run a profiling real quick and go into and have a look at how the results look here based on a test data set. And here we can see now that with the approach we took here, that we don't seem to have any unfair treatment across different nationalities. Obviously, there are some variants, like it's not all the same, but for us now, it's good enough. We don't have any like blatant unfair treatment here. So this is all cool. And now to kind of, as a last thing I want to show here in the part of this demo, one thing that is important lots of times is not only like when we put something in production to make sure it's actually fair, but also have the ability to look back to see, okay, where did something actually come from? Kind of have the traceability back to the past or to the front to see, did we actually do due diligence across the way? It's also something we have to do for auditing. And this tool here basically allows us to exactly do that, to have the lineage, to have auditability. And here we can see, for example, that we have this data set, CS accepts, which is connected to the credit risk modeling project where we have the models within. This project then is connected to models that are within it. For example, the Python model we have, but also the model pipeline we had before. And those two models, again, are then connected to the decision, which then again is connected to rule sets that live within that decision. So here you can see basically we have traceability and transparency, especially from the data set to the last bit of the decision. And that's something very, very powerful and important when we want to prove that we actually did due diligence across the way. Amazing. So because this was a lot and lots of things, we skipped over lots of things, but just to tie this a bit back to kind of like summarize what we just saw, we started with managing data. We started with a question. We started with, checking for privacy issues, data quality issues, and we saw if there's any bias in the data. We did that. Then we went over to develop models that are not only explainable, but also fair to a certain degree. And also then we went over to check that, we govern our models correctly. We have monitoring on them. So if anything happens, like data drifts or they deprecate over time, we make sure they perform up to our standards, and also that we can audit our decisions we are making. And across everything, we have accountability, because who did what, we know the handovers, it's all well documented. And before I want to go into closing, I want to go one step even further, because as I alluded before, this will be seen as a burden. This is seen as a burden. We have to comply with some regulations, but this can be so much more. This can actually be a real competitive advantage for two reasons. The first one is when we implement such a system that basically specifies steps, specifies handovers, automates things like DevOps did for software engineering quite some time ago, we drastically reduce the time from an idea to an implementation. We reduce cycle time. And I have real world experience with that. I saw customers having like time from idea to implementation for 6 months, 9 months, even sometimes. And when they adopted such processes, they get down to days sometimes. So from an idea to the modeling to the implementation to production system within literal days. And the second thing is, which is a bit cheeky, but we can be very sure that if there's regulation and we have to take account for everything, we will have to write documentation. And if we don't like one thing as developers, doesn't matter if it's deep software engineering or data scientist, we don't like writing documentation. Nobody likes that. And with all the metrics and all the answers and every check we did, we have already everything we need for such a thing. So technically, we could take all of this and fill it in a PDF template, for example, over a job that's running in the background, and we write a documentation by itself, basically, without even touching it. And that's not just an idea. We actually have done that. There's this toolkit called Veritas, which is an official toolkit, I think, by the Singaporean government or by the Veritas Consortium, where financial institutions have to use this already to kind of document their AI models. And we implemented or integrated this with the process you just saw, with the very process. And We have all the metrics that require, all the graphs that require, all the checks. We can just like within that process, create the PDF document, and we have the documentation ready without anybody even touching it. So yeah, it can be a competitive advantage if you embrace it. So, and in case you want more, there's actually an ebook. It's a bit, where you can read up like different facets. It's a very good point to get started because like it touches on very things you have to take care of, and that helps you to kind of like get an overview, and then you can dive deep into certain things. And if you're a bit more advanced already in like really like into modeling and want to learn about more the interpretability stuff I showed, there's a great free ebook from Christoph Molnar, Interpretable Machine Learning. I linked it here. It's very good, very interesting, very in-depth, and yeah. Also, hit me up on LinkedIn and Twitter. I'd like to talk about those stuff, other things, and also sometimes post interesting, blogs, videos, etc. about this topic.
Well, so one of the questions was actually about how to get in touch with us. You basically answered it here. So I will send a tweet, a direct message on Twitter, or I can get in touch with you on LinkedIn, right?
Yeah, definitely. Just hit me up. I'm a very regular there, and just if you have a question or anything, very easy, very straightforward. And last slide, I promise. If there's, because I know this was a lot, probably too much, but if there's 3 things I want you to remember, 3 things I really want you to take away from this, is that responsible AI is a multi-role effort. It's not the job of a person. It's not a job of a certain responsible AI or ethics team within an organization. Those are important, but it's not their job in the end. It takes everybody from data engineering to operations. Everybody has to be involved. It's everybody's job to make this a reality. The second thing is we need end-to-end processes. We need automated, repeatable processes to reduce overhead, to make sure we check all the boxes. We did every checks. Yeah, we need those processes because otherwise, we will get nowhere. And the third thing is don't exclusively see it as a burden and something we have to, even though it is a fact, but it can be and will be a competitive advantage if you can embrace it. And just like some stuff we came up with, I really saw adoption of those processes change analytical organizations. And if that's the excuse you need, well, go for it.
Okay, open that. Thanks for the summary. I think it's always good to have a summary in the end to see what we actually should have understood up to that point. Of course, I have a few more questions regarding what you said. I would be interested in understanding a little bit more about what regulation really means if you think about the whole process of AI and model development here in this case. So one thing is there a kind of, you have been talking about, you took the example of the finance industry, right? Of course, we have other industries as well, like manufacturing, production, those kind of things. Is there a kind of list of requirements which needs to be completed, which you really need to match in order to be compliant with regulation, with laws?
Well, that's a bit of a difficult question. Right now, there is no AI regulation. We don't have that yet. We know every major economy and also the European Union is working on it. And we get more and more information about how it's, what direction they're taking. But in fact, we don't have a set of things you have to check right now. It's not definitive. What we have, though, there is a paper from this group of the European Union that deals with it, that basically categorize different uses or different use cases of AI in different risk categories. So there's a forbidden categories that are basically not legal, and then there's I don't know how many tiers there are, but depending on the use case and depending on the how people are affected, there are different sets of requirements that will be met, and they already go a bit into detail here and tell you, okay, what kind of thing you will have to do. But it's not definitive. We don't know exactly what kind of certificates or what kind of checks you will have to do. So what I showed with Veritas, it's like very early, like they are a bit of ahead of us in this regard. But yeah, we will have to see what in the end we will need to do. But this doesn't change the fact that we will need a process, and we basically then just have to fill in the checks in the process we're going to build in the end.
Looking at the software you actually showed us from SaaS, so SaaS at least has an understanding of what might be interesting to measure if it comes to the feeds of the fairness, ethics, accountability, and transparency metrics, right? So you build some kind of measures into the software component, so you get an idea of how to manage it without even having regulation in place which demands you to do something.
Exactly. We really we actually have a data ethics practice team, and I think even the head of this data ethics team is kind of a, I don't know what the word is, but a kind of a consultant to the White House in the US to talk about data like AI ethics and stuff like that. So really, it's an important topic for us as an organization. We really want to kind of like pioneer the space and like really push things forward. So even though there is not regulation right now, we already really want to push people and give them transparency about what they're developing and help them to have fairer and better understandable models in the end.
One person question regarding how can we stay up to date with what's happening in the regulation space? Are there specific sources where you can stay informed, or how do you keep yourself informed?
That's also a thing. I mean, all sorts of communities are usually my go-to source. I mean, there is this one, I have to look up the name because I just forgot it, about this one group that like kind of works on this regulation right now. So listening to what they're saying. But I think as soon as there is definitive regulation, it will be known, like you will get the memo, I think. But if you want to like want to read up on more now, I think you just have to Google. There's not a single instance where I say this is the go-to source and you will definitely find everything. Unfortunately, right now the whole space is still like finding itself, and that's why information is a bit distributed.
Okay, thanks, Yannick, for taking the time to talk so long about that very interesting subject. And so we are basically at the end, and I know it's late evening, and you're probably also hungry already, looking for the dinner, which is probably next for you. So for anyone who's actually at a different time zone, maybe it's morning or it's afternoon, whatever time it is. Thanks again, everyone who has joined today, and it was a pleasure to have you on board here. And Yannick, again, very, very much thank you for this very detailed and very. I think you try to be quick and fast and not too long on many slides. Fantastic, good work. And but for anyone who has still questions left, get in touch with him. You saw there's a LinkedIn page where you can actually touch base. You can also send me emails. I can pass it on to him if there's some open questions left. Thanks again, everyone, and I wish you all a nice day, evening, afternoon, whatever it is. Thank you.
Thanks, everybody. And thanks, Stefan, for having me.
Yeah, thank you. Bye-bye.
Bye.